These topics are going to cover thermal conductivity and other thermal processes that we talked about after our Calor y Frio activity in class. So let's take a look. The first topic kind of discovered in class was something called thermal conductivity. Now if we take each word and kind of break it down, thermal means heat, right? Conductivity means how quickly energy is transferred. So here thermal conductivity means how quickly heat energy is transferred from one object to another. So for example, if we take a look at this warm body of water versus cold body of water, we can see that the thermal conductivity in this instance is going to go from the warm to the cooler body of water. And so our thermal conductivity goes from warm to cold. And like you saw in the activity today with the plastic versus the metal little discs that we were working with, thermal conductivity is going to depend on the material used, right? So we got some material science in here. Some materials are going to allow thermal conductivity to go quickly, okay, allowing energy to move from one object to another very quickly, while other materials will slow down thermal conductivity. Might even be what we call thermal resistors or thermal inhibitors. Okay, but what we're going to focus on is just the idea of thermal conductivity, meaning heat energy transferring from one object to another. And in general, heat energy, just like we saw in the previous example, always flows from hot to cold. Okay, so heat energy or thermal energy flows from higher temperatures, meaning hot objects, to lower temperatures, meaning the colder objects, right? And heat energy is going to flow until they reach the same temperature, right? So if we take a look at the example over here, we've got a block that's 100 degrees Celsius and a block that's 20 degrees Celsius. If we move them next to each other, okay, we're going to have a transfer of heat. The heat from the 100 degrees Celsius block is going to go into the 20 degrees Celsius block. That's the order and consistency of nature here, to always flow from high concentration to low concentration. And in this instance, it's the high concentration of temperature, thermal energy, to the lower concentration of thermal energy. And that's going to take place until equilibrium is reached. And that just means that they are both the same temperature then, right? So if you take, a look at, around you in your room, all right, everything is probably at the same temperature, thermal equilibrium, unless you've got a stove on or you've got, an ice pack that's fresh out of the freezer. Everything around you is going to be at the same temperature because they're all at thermal equilibrium. So, like we had mentioned earlier, different objects are going to absorb and emit heat at different rates. Remember, in our activity, the metal quarters sucked or absorbed heat really quickly, right, to melt the ice. And then the plastic was a lot slower in melting the ice. And that's because we've got different types of materials that have different thermal conductivity rates. Okay. So metals typically are fast thermal conductors, and plastics, woods, and other objects like that are typically slower at thermal conductivity than metals. All right, so let's take a look at some examples and take a look at the idea of temperature and thermal conductivity. So temperature is the average kinetic energy of an object or a substance. And so when objects lose heat, their temperature is going to drop, obviously, right? It's kind of like a duh statement. If you're losing heat, then your temperature is dropping because that heat is going away out of you, right? On the other hand, when objects gain heat, their temperatures rise. So if you go out in the sun and you're gaining heat, your temperature, if you take your temperature, it's going to rise. It may even get into like the quote-unquote fever zone. So that's just kind of common sense in terms of temperature and losing or gaining heat. So let's take a look at these blocks. And I apologize for the formatting error that happened on this slide, but this should say, should not be 250 C, it's 25 degrees Celsius, all right? So we have a block that's 25 degrees Celsius and another block that's 0 degrees Celsius. And if they come in contact with each other, okay, we bring them together. Remember, heat always flows from high to low, right? So we're going to get thermal conductivity going in this direction, okay, from the 25 degrees Celsius to the 0 degrees Celsius. And that's going to occur until what? Until it reaches thermal equilibrium. So the 25 degree block is going to lose heat, so its temperature is going to go down, right? The 0 degrees Celsius block is going to gain heat, and therefore its temperature is going to rise. And there will be one point where they are going to reach the same temperature, and then it's going to stop. Okay, that thermal conductivity or heat flow is going to stop. Let's take a look at the second example. So here we've got a 100 degrees Celsius, actually we have two 100 degrees Celsius objects, right? So this should say 100 degrees Celsius. If we bring them together, okay, we put them together, what will happen? Do we have a block that is higher temperature than the other? No, they're both the same temperature. So will heat move at all in this situation? Okay, the answer is no. There's going to be no thermal conductivity whatsoever. Okay, because they're both the same temperature, right? They both have the same amount of energy. And so they're already at thermal equilibrium. So two 100 degree objects next to each other are at thermal equilibrium already. So heat flow will not take place, and we're not going to see any rise or drop in temperature, okay, between these two blocks. So we do have to keep that in mind. That's kind of a trickier type question with this thermal conductivity. It always goes from a high temperature substance to a low temperature substance until thermal equilibrium is reached. And if two objects are already the same temperature, then they're already at thermal equilibrium. So no heat flow or thermal conductivity occurs. All right, so focusing on the object itself and what happens when temperatures drop or rise is what we're going to take a look at in these last two slides. Okay, so we've got an exothermic and an endothermic process, and you've probably heard these terms before, but let's take a look at each of these and review what it means. So when an object's temperature drops, that means it lost heat to the environment, right? So it's giving away heat because the temperature is dropping. All right, it's losing heat to the environment. So you are the environment of that object. All right, so if you are touching a hot pan, that hot pan is releasing heat to the environment. Its temperature is starting to decrease, but it's going to feel super hot to you because all that heat that's being lost is now going to you. So this is what we call an exothermic process. Exothermic processes always feel hot, okay? Exothermic processes always feel hot. Here's just a simple illustration. Here we've got some hot water, and again, these arrows indicate that it's losing heat to the environment. So if you put your hand, there you go, there's a hand over that beaker, you will feel the heat that it's being lost, okay? And this is what we call an exothermic process, when objects lose heat to their environment. So combustion reactions are a good example of exothermic processes. This is anything that's burning is a combustion type reaction. Okay, so burning wood, the combustion reaction inside of your car, okay, anything like that. So it's letting off heat and therefore an exothermic process. Now, the opposite is what we call an endothermic process. An endothermic process is when an object's temperature rises. So what that means is that object is sucking or gaining heat from the environment. So over time, the object's temperature is going to increase because it's getting heat from its environment. So what this means is that it's going to feel cold to you. Okay, and the reason why it feels cold is because it is taking the heat away from you. All right, so heat is being transferred from you to it because it is gaining heat, and therefore its temperature is rising. So this is what we call an endothermic process. In this case, you can see that the energy arrows are going into the substance, and if your hand, right, my lovely hand was over it, it would feel cold because it is drawing the heat from you into itself. So this is what was happening when you're holding the ice cube in your hand. The ice cube was actually drawing heat from your hand into itself and raising its temperature. All right, because when ice cubes raise their temperature, they start to melt. So we have evidence of that. Right, so that's what we call an endothermic process. So this was our notes on our wrap-up for the Calor y Frio activity that we did today in class.